Hi Year 13 and welcome to your weekly introduction videos. We're going to continue with vectors and we're going to look at sort of some more advanced stuff and some applications of vectors, okay? But it's vitally important that you've understood last week's work. If you haven't, then none of this is going to make sense, okay? So we're going to look at the dot product of a vector and the cross product of a vector. So these are two ways in which we can multiply vectors together. And both of these things have useful properties. Okay, so I'll explain more clearly what they are. Then we're going to look at how we might find the angle between two vectors. We're going to find the vector equation of a line, and we can use the vector equation of a line to find parametric and Cartesian equations of a three-dimensional line. Obviously, at the moment, you know that you can do a two-dimensional line as y equals mx plus c. It is a Cartesian equation of a two-dimensional line, but you can also do it in 3 dimensions, okay? And, basically just following on from that, then you should then be able to find the angle between two lines. Whether you have the lines in a vector equation form, parametric equation, or a Cartesian equation. So probably a lot of stuff here that, a lot of words that don't make any sense at the moment, but hopefully by the end of these videos you'll know what I'm talking about. Okay. Now, first thing we need to know is we can find what is known as the dot product of two vectors. Okay. It's basically a way of multiplying two vectors together, and the result that you get is just a number, okay? It's a scalar, it's just a value, okay? And it follows the formulas that you've got here, and it works in 2 and in 3 dimensions, okay? So basically, if you just follow the formula, if we look at A, the dot product simply says it's going to be 2 times 1 plus 3 times 4. So that's going to be 2 plus 12 is 14. Okay, that is the dot product of these two vectors is equal to 14. Now this does have a geometric representation. It is something that you're physically doing with the vectors, but I don't want to get into that too much just now. I'll sort of mention it in a bit more detail a little bit down the line in the video. I just want you to be able to calculate the dot product at this point. So also works in 3 dimensions with a x, y, z vector. So it'd be minus 1 times 3 plus 2 times 1 plus 4 times 2. So it's minus 3 plus 2 plus 8 equals 7. So the dot product of these two vectors is 7. Okay, and these dot products follow the general rules of algebra. Okay, so if we want to know the dot product of A dot B, well, that's the same as B dot A. The same as 3 times 7 is equal to 7 times 3. Well, so is the case that if I turn these around, 3, 1, 2 dot minus 1, 2, 4, I get the same dot product of 7. Okay, if I find the dot product of the same vector, that is the same as the magnitude squared, okay? And we can distribute things as well, just like, with brackets. So A dot B plus C is equal to the dot product of AB plus the dot product of AC, and the same with double brackets, okay? You can sort of expand the brackets and work just like normal algebra, okay? So this is what is known as the dot product. So it's a way of multiplying two vectors together such that the answer you get is a number. Okay? Now, why is that useful? Okay? The reason why that is useful is because it can help us to find the angle between two vectors. Okay? And there is a formula for finding the angle between two vectors. Now, normally I would spend some time proving this formula to you, probably give it to you as an exercise, but we just simply don't have the time. With everything that's gone on, I'm not going to be proving many formulas anymore. We just have to get on. Okay, so it's a bit sloppy, a bit lax from me. But this can be proved basically using the cosine rule. So what we can say is the cosine of the angle between two vectors. So let's say I've got a vector here and a vector here. Okay, this is vector A and this is vector B. Then we can find the angle between those two vectors. And the angle between the two vectors is the dot product divided by the product of the magnitudes of the two vectors. Okay? So, we can find out the cosine of the angle of P and Q in this question by finding the dot product first. So that's going to be 2 times minus 1 plus 3 times 0 plus minus 1 times 2 divided by the magnitude of P, which is the square root of 2 squared plus 3 squared plus minus 1 squared, just a bit of Pythagoras there, times the square root of minus 1 squared plus 2 squared. Okay, so we're going to get negative 4 in the numerator, negative 4, over the square root of 4 plus 9 plus 1. That's the square root of 14. And then 1 plus times the square root of 5. So we can say cosine theta is equal to negative 4 over root 14 root 5. So theta is equal to inverse arc cos negative 4 over root 14 root 15. So I'm just going to throw that into my calculator. So we're going to do minus 4 divided by, use a bracket, square root of 14 times the square root of 15. Okay, and that is equal to minus 0.276, blah, 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 blah. So I'm going to do shift inverse cosine of the answer. And the answer is 106.02 degrees to 2 decimal places. Typically, when we're dealing in vectors and I want to find the angle between two vectors, we answer in degrees. But you need to read the questions carefully and understand, do they want degrees or do they want radians? Okay. Now, just a little extra thing you need to think about. And clearly here, what we got was a obtuse angle. Now, between two vectors, because remember a vector is just a direction, you're actually going to get two angles between them, and one is going to be acute and one is obtuse. So clearly the angle, we've managed to find the obtuse angle. The acute angle is simply going to be 180 minus 106.02. So 180 minus my answer equals 73.97 degrees to 2 decimal places, if they want the acute angle. Okay, so we can use this formula to find out the angle between two vectors using the dot product. Okay, so I hope that makes sense. So hopefully some obvious things come out of this. Okay, firstly, if A dot B is equal to 0, then when you're trying to find the angle, you're going to get A dot B is 0, then it really doesn't matter what the magnitudes of the two vectors are. That's still going to be equal to 0 because the denominator is 0. So you're going to end up with cosine theta is equal to 0, and therefore using the graphs or using your calculator, you can tell me that theta is equal to 90 degrees. So if A dot B, if the dot product of A and B is equal to 0, then those two vectors must be perpendicular to each other. okay? And you're going to find out next week, possibly the week after, or maybe after your mocks actually, I don't know. But to be able to find out two vectors that are perpendicular to each other is a very, very useful thing indeed. It's very, very useful. And of course, also what will happen if you end up with two vectors that are parallel, well, if two vectors are parallel, then the angle between them is 0. So you've got A, just a simple rearrangement of the formula would say A dot B is equal to the magnitude of A times the magnitude of B times cosine of your angle. Well, if the angle is 0, cosine of 0 is equal to 1, so that would imply that A dot B is equal to the magnitude of A times the magnitude of B. So that would imply, this result here would imply that you've got two vectors that are parallel. So there's another way of establishing that two vectors are in fact parallel. If the dot product is equal to the magnitudes multiplied together, then the two vectors must be parallel. Okay? Right, so now we can start to use vector methods to determine angles that we might be interested in. So we want to use vector methods to determine the measure of ABC, the angle ABC. So what we want is, let's just draw a line AB and then draw a line BC. Okay, so we're working in 3 dimensions. What we want to know is what is this angle. Okay, we can use vectors to do that. What we first of all is we come up with a arbitrary point of A. We're going to let A be the origin, 0, 0, 0. Well, if that is the case, just looking at the dimensions we got, B must be 4, 3, 2. Okay, so that's 4 along, 3 up, and 2 back. Okay, 4, 3, 2. And what else do we know? We know that C is equal to, well, 4 along and 1 back. So 4 along, 0 up or down, and 1 back. Okay? So we're able to find these points, which means that the vector AB is equal to 4, 3, 2. Essentially, because I've made A the origin, I've turned AB into a position vector. Okay? And same, I can actually find out what BC is. BC, well, BC is going to be AC, sorry, no, what am I doing? I'm trying to find BC, so I'm going to have to go, yeah, I was right. It's AC minus AB, because basically to go from B to C, I'm going to go the wrong direction in AB, and then I'm going to go in the vector AC plus AC. So I get AC minus AB, which is 4, 3, 2. Sorry, that's wrong. AC is 4, 0, 1 minus AB, which is 4, 3, 2. So I'm going to get 0, -3, -1. So what I want to do is I basically need to find out the angle between, what I'm now going to draw is these two vectors here. Okay, now I'm going to tell you now that I think the result I'm going to get is actually going to be a obtuse angle, okay, when actually clearly my angle needs to be acute. And the reason why I think that's the case, I might be wrong, is because the A to B and B to C, you notice they're sort of going in the wrong directions. They're not both going towards the point B. So what I'm really doing is I'm finding out this angle here, because that is where the arrow is both going away from that point. So what I'm really doing is finding this angle, which is going to be the obtuse one. But obviously once I find it, I can just do 180 minus my answer, and that will give me the acute angle. Okay, so let's just try and do it. So cosine of my angle is going to be equal to the dot product. So that's 4 times 0 is 4 times 0, plus minus 3 times 3, plus 2 times minus 1, over the magnitude of each one, 4 squared plus 3 squared plus 2 squared, and square root, times minus 3 squared plus minus 1 squared. Okay, so that's going to be minus 9, minus 2 is minus 11 in the numerator, over 16 plus 9 plus 4, which is what, root 29? And 9 plus 1 is root 10. So that's cosine of my angle. So now I'm just going to throw that into a calculator. So you get minus 11 divided by root 29 root 10. Okay, and then shift cosine to the minus 1 of your answer equals 130.2 degrees to 1 decimal place, and I was right. So I ended up with a obtuse angle, which clearly my angle ABC is not obtuse. So I can easily find out what it is. It's just going to be 180 minus that, which is 49.8 degrees to 1 decimal place. Okay, so let me just clear about what happened there. What I'm saying is, if I have my two arrows pointing both towards the point or pointing both away from the point, then I will be finding that angle there. But if I have a situation where one is pointing in this direction and one is pointing in this direction, then I will not be finding this angle. What I'll actually be finding is this angle here. Because in this case, one is pointing towards the point and the other is pointing away from the point. So I wouldn't be finding this angle, I'd be finding